So finishing off a few questions with AER, or annual equivalent rate. And once again, remember APR and AER, they're pretty much the same thing. This is just one of the questions where they would ask you for the AER, not the APR, but it doesn't really mean anything. It's just like you'd sometimes see AER in more context than APR, but they're the same meaning overall. Okay, so analysing this question, a 16-month fixed-term saving account offers a return of 5%. What does that mean? Well, 16-month fixed-term savings account basically means the fixed term means if you put your money in to this account 16 months later, once you put it into the account, you're not allowed to touch it for 16 months. 16 months later, then you're allowed to take it out, and once you've taken it out, it will have increased by 5%. So you put it in at the start of the 16 months, okay, you leave it for 16 months, and then it comes out. If you put in 1 at the start, what would come out? 1.05 would come out. Okay, so that's the idea of a fixed term savings account. We're asked what is the AER of this account. So what is the annual equivalent rate? Well, obviously there are 12 months in a year. So basically what they're asking us here is what is the equivalent percentage rate per year theoretically given this 16 months. So you wouldn't be able to get this, whatever this AER is in this account, because you're only allowed to put it in at the start and take it out at the end of the 16 months. But it's just kind of easier to compare something at an annual equivalent rate than at a 16-month rate. So basically just trying to find what the equivalent yearly rate is for this account. Now, a mistake to do would be to think, okay, 5% for 16 months. So then I'm just going to divide 5 by 16 to get each month and multiply by 12 to get the whole year. That'll be wrong, okay? Because remember that this is compound interest. So over the 16 months, it changes depending on the amount in the account per specific time. So we have to factor that into the AER calculations. Do not do this. This would work for simple interest, but this is not simple interest. Always for these sorts of questions, you can assume it is compound interest. So let's break this down into a formula. Well, we're going to use the same one we usually do. F equals P times 1 plus I to the T from the log tables. Okay, so our final value, again, we're not given an amount that's invested, so we can just use 1. Remember, you can use any number. You can use 100, 1,000, 200, but the easiest one to work with is just 1. So my final value is going to be 1.05 because that is what I take out of the account. 1's put into the account. And we do 1 plus I to the power of t. So we're going to focus on these I and t. So why isn't I 0.5? I here represents the AER. I equals AER. And t represents number of years. Okay, so 1.05 is the amount that this is increased to after 16 months. So how many months are in a year? 12 months. So that means 1 year is equal to 12 over 12 months. What does that mean 16 months is equal to in terms of years? 16 months in terms of years is going to be 16 over 12. So that's the amount of time that this investment has been invested, 16 over 12 years. Just think of it as a fraction. So we can fill that in now. And remember, we're trying to find I equals AER, the annual equivalent rate. So we don't have an answer for that straight away. So 1 plus I to the power of 16 over 12. So basically what this is saying is, if I invest €1 for 16 months at 5%, I'll get 1.05 at the end. What annual rate could I invest for 16/12ths of a year to get the same equivalent rate? So I'm continuing that over here. So first of all, the 1 can go because it's just 1, doesn't mean anything. Next, then we want to get rid of the power. How do we usually get rid of a power? Well, we can actually simplify this down into a decimal first just to make it a bit more workable. You don't have to, but it's probably easier. So it'd actually be 1.333 there, or 4 over 3. I'm not going to do the 1.333 because then it's a bit awkward. I'll just use 4 over 3 for this. So what do we usually do to get rid of a power number? We get the square root of both sides with the little number here. And again, you don't have to worry why you do that, or what this means, I mean, because we know it cancels and we know it works and we have the calculator to do it. So it cancels on that side, we're left with just 1 plus I. And on this side, type it in the calculator, we end up with 1.037. So that means our I is going to be 0.037. So I is equal to 3.7%, which is the annual equivalent rate. So if you invested say an account offered a 3.7% annual rate and you were able to invest it for 16 months, this would give you overall 1.05 return over the 16 months. So this is a sort of question that would come up quite regularly, but maybe in a different form. I'm going to now do a question that's in the book, an example, which will be kind of the backwards version of this question. Okay, so this is from page 252 in the book. A loan advert quotes an APR of 40.9%. See, APR, once again, it's kind of interchangeable with AER, doesn't matter. So every year you get 40.9% interest. Or sorry, you'd be charged 40.9% interest. Find correct four significant figures, the equivalent rate of interest if compounded monthly. So basically, what is the equivalent in monthly interest? As in, how much interest are you having to pay every month that gives you over the 1 year your 14.9% interest? What's the equivalent rate per month? So this might be just for budgeting or something that might be useful. This is a very common question. Once again, we're not given a figure. We do know, well, once again, actually, we're going to use the formula F equals P plus 1 plus I to the T, but we're not given a figure, as in we don't know how much was borrowed. So just assume you could do it anything, but we're just going to say it's 1. Okay, so if I invested €1, how much would I owe by the, sorry, if I borrowed €1, how much would I owe by the end of the year? I would owe €1.149. How much did I borrow? I borrowed 1, the principal amount. 1 plus I is the I now is going to be the monthly amount because we're making it that. Monthly interest. The equivalent rate per month. And T is going to be the number of months. So, how many months are in 1 year? How many months do I invest this in to get this 1.149? I've invested it for a year, the annual percentage rate. So it's going to be 12 months. So now it's back to what we did before. The 1 can go. How do we get rid of the power? We get the root 12 of both sides. So root 12 and root 12. They go. We're left with 1 plus I here and 1.012 here. So this will mean that our interest rate, or I, will be 0.012, which is going to be 1.2%. So that's my equivalent monthly interest rate. If I invested whatever, or if I borrowed this for 12 months at this interest rate over the whole year, I would have to pay 14.9% interest. So another example again, we're told a credit union loan charges biannual interest at an annual equivalent rate of 10%. What is the rate of interest for each compounding period? So each compounding period, when are we told what's the period length that the interest has to be paid on? It's not yearly, it's biannual. Biannual means twice a year. So there's a lot of equivalents of these. You might have quarter annually, every quarter, or monthly like we saw, or every 3 months, whatever. Twice a year. So we know that you will be charged interest twice a year, but overall the equivalent annual rate of once a year would be 10%. So same thing again. If we're using our same formula, F equals P 1 plus I to the T. My final value is going to be 1.1 because I've borrowed €1. We're made it up again, same thing. We're borrowing €1 just like I did in the previous examples. And after a year, it's going to be 1.1 euro. So 1.1 plus I, sorry, because this I represents the biannual rate, interest rate. And how many periods are we investing it for to get our 1.1? Well, if it's twice a year, this interest, and overall the equivalent of that is 10% over the whole year, how many twice a years are there in 1 year? Obviously, there's going to be 2 twice a years in 1 year. So I've invested at biannual rate for 2 years at this, whatever this interest is, and I got 1.1% overall. So this will end up with, how do we get rid of the 2? We get root and root, 2 and 2. We end up with 1 plus I, and on this side 1.049. So that means our I is equal to 0.049. I is equal to 4.9%. So that's the equivalent biannual interest rate. Instead of the annual rate of being 10%. See, it's slightly less than just half of that because of the compounding taken into account. So you should now be able to do question 26 and question 31 to 34 in the book.